Can you imagine a future where diseases are diagnosed accurately and in a timely manner, not by human doctors but by intelligent machines? Welcome to the dawn of artificial intelligence in healthcare, a revolution that is changing the face of medical diagnostics. This isn't science fiction. It's happening right now, and it's transforming the way we understand and tackle diseases. Harnessing the power of machine learning and deep learning, AI algorithms are learning to identify diseases with a level of accuracy that could soon surpass human capabilities. These intelligent machines are not just crunching numbers and reading data, they're making sense of complex medical images, spotting patterns that the human eye may miss, and predicting disease progression with remarkable precision. The potential benefits are immense. Think of a world where diagnostic errors are significantly reduced, where the decision-making process is enhanced, and where patients get accurate diagnoses quickly. This is the future we're looking at with AI in medical diagnosis. But it's not all rosy. There are challenges, limitations, and ethical conundrums to navigate. Yet, the promise of this technology is undeniable. Indeed, the future of medical diagnosis looks promising with the advent of AI. Artificial intelligence, a term that has become a buzzword in many industries, is making significant strides in the field of medical diagnosis. As a concept, artificial intelligence, or AI as it's fondly called, is a branch of computer science that aims to imbue software with the ability to analyze its environment and make decisions with some degree of autonomy. In simpler terms, it's all about creating smart machines that can mimic human intelligence. Now, you might wonder, how does this apply to medical diagnosis? Well, AI uses algorithms and computational models to analyze vast amounts of data, identify patterns, and make predictions. In the context of healthcare, this means AI can sift through countless medical records, images, and research papers and unearth insights that might be difficult or even impossible for humans to find manually. Consider this. A doctor, however experienced, can only remember and analyze so much information. But an AI system, it can process and learn from billions of data points, from symptoms and medical histories, to genetic information and even notes from similar cases around the globe. It's like having a superhuman doctor who never sleeps, never forgets a detail, and constantly learns from every medical case ever recorded. But it's not just about the volume of data. AI also excels in identifying patterns and making predictions. It can spot subtle signs of disease in medical images, predict the risk of future health issues, and even suggest the most effective treatment options based on a patient's unique profile. For instance, machine learning, a subset of AI, uses algorithms like support vector machine and deep learning leverages convolutional neural networks. These techniques are particularly effective in analyzing medical images and have been used to diagnose diseases with impressive accuracy. With AI, we are stepping into a new era of medical diagnosis, an era defined by speed, precision, and personalized care. An era where doctors are equipped with a powerful tool that can help them make more informed decisions, and ultimately, improve patient outcomes. As we delve deeper into this topic, we'll uncover how these AI techniques work, their benefits, challenges, and their potential impact on medical professionals and patients alike. Stay tuned. One of the key techniques used in AI-powered medical diagnosis is machine learning. Machine learning, often abbreviated as ML, is a subset of artificial intelligence that enables systems to automatically learn and improve from experience without being explicitly programmed. It's like teaching a child to recognize shapes. You show them examples of circles, squares, and triangles, and over time, they learn to identify these shapes on their own. Similarly, in the medical field, machine learning algorithms are fed vast amounts of data, such as medical images or patient histories, and they learn to identify patterns that may be indicative of a particular disease. Support vector machine, or SVM, is one such algorithm that has proven to be particularly effective in medical diagnosis. SVM is a supervised learning model, meaning it learns from labeled data. For instance, if we feed an SVM algorithm thousands of chest X-ray images, some labeled as normal, and others labeled with specific conditions like pneumonia, the algorithm learns to differentiate between normal and pneumonia-afflicted lungs. However, The effectiveness of these algorithms is largely dependent on the quality of the data they are trained on. This is where data pre-processing and feature extraction come into play. Data pre-processing involves cleaning and transforming raw data to make it suitable for machine learning algorithms. It's like washing and chopping vegetables before you can cook them. Feature extraction, on the other hand, is about identifying the most relevant pieces of information from the data. It's akin to a doctor focusing on specific symptoms to diagnose a disease. For instance, in the case of the chest X-rays, certain characteristics like the opacity of the lungs or the presence of abnormalities may be extracted as features for the SVM algorithm to learn from. With the power of machine learning, we can now analyze medical data with a level of precision and speed that was unimaginable just a few decades ago. It's like having a superhuman doctor who can review thousands of medical images in the blink of an eye, never gets tired, and keeps improving with every new piece of information it encounters. However, it's crucial to remember that these algorithms are just tools. They are incredibly powerful tools, but tools nonetheless. They don't replace doctors, but rather, they augment their capabilities, enabling them to make more accurate diagnoses faster. Machine learning is undoubtedly a powerful tool in disease diagnosis. It's transforming the medical field as we know it, helping us move towards a future where diseases are identified earlier, treatments are more effective, and patients live healthier, longer lives. Another technique that is making waves in the field of medical diagnosis is deep learning. Now, you may be wondering, what exactly is this deep learning? Well, it's a subset of machine learning, which is in turn a subset of artificial intelligence. But what sets it apart is its ability to learn from data that is unstructured or unlabeled. This makes it an ideal tool for medical image analysis, where the data can be highly complex and varied. Now, let's dive a little deeper into how deep learning works in the context of medical diagnosis. One of the most common types of deep learning algorithms used in this field is a convolutional neural network, or CNN. CNNs are inspired by the biological processes of the human brain and are particularly effective in processing visual information. They work by scanning an image, identifying distinctive features, and using these features to make a diagnosis. For example, consider a chest X-ray image. A CNN would scan this image and could identify features such as lung nodules, a common indicator of lung cancer. It's like having an exceptionally skilled radiologist who never gets tired or distracted, working around the clock. But it's not just about identifying features. A crucial aspect of deep learning is model training. This involves feeding the model a large amount of data, allowing it to learn and refine its ability to make accurate predictions. The more data the model is trained on, the more accurate it becomes. This is why data collection and pre-processing are such vital steps in the process. Model training also involves a process called backpropagation, where the model adjusts its internal parameters to minimize the difference between its predictions and the actual outcomes. This iterative process allows the model to continuously improve over time. But it's important to remember that while the capabilities of deep learning are remarkable, it's not a magic bullet. It's a tool. And like any tool, it's only as good as the person or team who uses it. It requires careful implementation and oversight to ensure it's used responsibly and effectively. Deep learning, with its remarkable capabilities, is transforming the way we diagnose diseases. It's an exciting time in the field of medical diagnosis, and it's just the beginning. As the technology continues to evolve, who knows what incredible advancements are just around the corner. While the benefits of AI in medical diagnosis are numerous, it's not without its challenges. In the realm of medical diagnosis, artificial intelligence has been a game changer. It has been instrumental in reducing errors and improving diagnostic accuracy. The way it does this is by analyzing vast amounts of data swiftly and accurately, something that would be near impossible for humans to do with the same speed and precision. For instance, through the use of machine learning and deep learning algorithms like support vector machine and convolutional neural network, AI can analyze medical images to identify diseases with a high degree of accuracy. But it's not just about accuracy. AI also enhances the decision-making process in medical diagnosis. It can provide doctors with a wealth of information, helping them make more informed decisions about a patient's care. In essence, AI acts as a powerful tool that supports medical professionals in their work, enabling them to deliver better patient outcomes. However, despite these benefits, it's important to acknowledge that AI in medical diagnosis is not without its challenges. One of the major hurdles is data preprocessing. This is the process of cleaning and organizing data before it can be used in AI algorithms. It's a crucial step, but it can be time-consuming and complex. Another challenge is feature extraction. This involves identifying the key elements within the data that are relevant for the task at hand. It's a critical component of the process, but it's also one that requires a high level of expertise and precision. Model training is yet another challenge. This is where the AI learns from the data to make accurate predictions. It's a complex process that requires significant computational resources and expertise. Moreover, there are ethical considerations that come into play. Issues such as data privacy and the potential for bias in AI algorithms are matters that need to be carefully managed. Despite these challenges, the benefits of AI in medical diagnosis are too significant to ignore. With its ability to reduce errors, improve diagnostic accuracy, and enhance decision-making processes, AI has the potential to revolutionize the field of medical diagnosis. And while it may not be a silver bullet, it's a powerful tool that can greatly improve the way we diagnose and treat diseases. So while the road to fully integrating AI into medical diagnosis might be fraught with challenges, it's a journey that promises significant rewards. As we continue to innovate and refine these technologies, the potential for AI to improve patient outcomes and transform the healthcare industry becomes all the more apparent. Despite the challenges, the benefits of AI in medical diagnosis are too significant to ignore. AI is not here to replace medical professionals, but rather to augment their capabilities. Artificial intelligence, or AI, is a tool, an ally, and a revolutionary companion in the realm of healthcare. It's transforming the way medical professionals work, enhancing their abilities to diagnose, predict, and treat diseases. Think of AI as a high-tech magnifying glass. It doesn't make the decisions. It merely brings the minute details into sharp focus, allowing doctors to see more clearly and make more informed decisions. For instance, machine learning and deep learning algorithms like the support vector machine and convolutional neural network are particularly effective in medical image analysis. They can pick up subtle patterns and signals that might be missed by the human eye, making for more accurate diagnoses. AI also acts as a tireless research assistant, tirelessly sifting through volumes of medical data, identifying patterns, and providing insights that can lead to groundbreaking treatments. It's like having a super-powered librarian who can read through thousands of medical journals in the blink of an eye and then present the most relevant information in an easily digestible format. But the impact of AI goes beyond diagnostics and research. It's changing the very roles and responsibilities of medical professionals. Routine tasks like analyzing lab results or medical imaging can be automated, freeing up doctors to focus on the more complex aspects of patient care. It's not about machines taking over jobs, but rather about machines taking over tasks. AI also opens up new avenues for personalized medicine. By analyzing a patient's genetic makeup, lifestyle, and environmental factors, AI can help doctors tailor treatments to the individual, improving outcomes and potentially saving lives. In fact, the integration of AI into medical practice is fostering a new era of healthcare, one where human expertise and artificial intelligence work hand in hand. It's a partnership that promises to enhance the efficiency, accuracy, and personalization of care. With AI, medical professionals can do more than ever before. AI is a game changer, a force multiplier, and an invaluable asset that's helping medical professionals push the boundaries of what's possible in healthcare. It's not about replacing the human touch. It's about empowering it, amplifying it, and taking it to new heights. AI is here to stay, and it's reshaping the future of medicine, one diagnosis at a time. The integration of AI into the field of medical diagnosis is an exciting development. We've explored its potential, delving into the techniques of machine learning and deep learning, and their transformative power in disease identification with unprecedented accuracy. We've seen the benefits, like reduced errors and improved decision-making, but also acknowledged the challenges, like data pre-processing and model training. Looking ahead, the prospects are thrilling. Imagine a world where AI doesn't just support, but leads the diagnostic process, identifying diseases before symptoms even surface. Picture a healthcare system where AI-powered algorithms, such as support vector machine and convolutional neural network, not only analyze medical images but predict potential health risks, allowing for early intervention and improved patient outcomes. The future of AI in medical diagnosis isn't just about technology. It's about people, about saving lives and enhancing the quality of life. As we look forward, the role of AI in medical diagnosis is set to become even more prominent, heralding a new era in healthcare.